In the previous video, we used the hierarchy of connectives to determine the correct order in which to set up the columns for the truth table for this expression. The second thing you need to know to complete the truth table is the rules for completing the columns for each of these connectives: conjunction, disjunction, conditional, biconditional, and negation. Each of these individually have their own rules, their own truth tables, I should say, but you could also describe them in words, making the truth tables unnecessary to memorize for these. For example, the rule for conjunction is it is true only if, let me write the word true. True only if all t's. The rule for disjunction is false only if all f's. So they're similar. One is focusing on true, one is focusing on false. There's a way to remember which is which if you remember that conjunction is the symbol for the word and disjunction is the symbol for the word or. It's easy to remember that conjunction is the symbol for the word and because the symbol looks like a capital A, and of course, and starts with A. It's good to have an example to fall back on. So let's say that I say, raise your hand if you are female and you were born in Texas, and somebody raises their hand. That means that they are female is true, and they were born in Texas is true. In other words, if you say an and statement and the statement is true, that means all of it is true. So the only way an and statement is true is if all of it is true, every single part of it. I am a teacher, and I am a father, and I have a master's degree in mathematics, and I have a bachelor's degree in mathematics. That statement is true because each individual statement was true. However, if any of them were false, then the whole statement would be false. I'm a teacher, and I'm a father, and I have a master's degree in mathematics, and I have a bachelor's degree in history. That last part made it false because the only way an and statement can be true is if all of it is true. Similarly, for a disjunction, which is the symbol for the word or, an or statement is true if any piece of it is true. So for example, if I said I am a teacher and I am if I said I am a teacher or I am a grandfather or I have a master's degree in psychology or I have a bachelor's degree in music, that statement would be true. Even though I don't have a bachelor's degree in music and I don't have a master's degree in psychology and I'm not a grandfather, I am a teacher. But because I am a teacher and I said the word or, the whole statement was true just because one piece of it was. Like if I said raise your hand if you're female or you were born in Texas, I could raise my hand. Why? Because at least one of those is true. The only person who could not raise their hand is if all of it was false. So for example, if I said I am a chef, or I am a grandfather, or I have a master's degree in psychology, or I have a bachelor's degree in fine arts, that statement would be false because every single piece of it was false. The only time an or statement is false is if all of it is false. For a conditional, which is the symbol for the phrase if then, the rule for conditional is it is false only if T points to F. In class, this is what I refer to as breaking a promise. A conditional is like a promise. If this happens, then that's going to happen. If I graduate in May, then I will get a job. What would have to happen for that statement to be false? Again, the statement is, if I graduate in May, then I will get a job. In order for that to be false, I would have had to graduate in May, but not gotten a job. In other words, the first part of the statement, the if part, would be true, but the follow-up, the then part, would be false. So the only time a conditional is false is if the first part is true, the if part is true, but the then part is false. You've broken your promise. The biconditional, which is the name of a statement that contains if and only if, has a pretty easy rule. A biconditional is true only if both halves match. So the biconditional is kind of like an equal sign. Are my truth values equal? When I say both halves match, I mean T double arrow T or F double arrow F. So if they don't match, then the biconditional is false. And the rule for negation is easy. The rule for negation is you just change the truth value. So if a statement is true, then its negation is false. And if a statement is false, then its negation is true. By knowing and using these 5 rules, we can complete every column in that truth table. So the 2 key things you need to know to set up and execute a truth table are the hierarchy of logical connectives, what order you're going to set up the columns in, and the rules for completing the columns based on the connective used to build the rule. In the next video, we'll actually complete the truth table.